Isoprene. Historical significance of the compound. Rubber was first used by Indian tribes of the Amazon basin. Rubber balls date back to between 1600 to 1200 BC in Mexico. The Omegas Indians of Ecuador used rubber as balls, containers, boots, and hats. Rubber comes from the sap of trees and plants such as Ficus elastica, Castilla elastica, Parthenium argentatum, plants that are in the Euphorbia family, and the greatest natural rubber producer, Hevea brasiliensis, all of which you can see here. The amount of rubber found in South America and the Amazon rainforests affect the economy so much that it caused Manaus to have the greatest number of diamond purchases in the world at one point. When Englishman Henry Alexander Wickham went to the Amazon rainforests, he brought rubber tree seeds back to Britain with him, leading Britain to have over 10 million rubber trees by 1907 after starting a great rubber dynasty in Asia. Africa was also affected by the discovery of rubber, as traders would hold Africans in the Congo hostage for red rubber. The rubber from the Congo was used by Leopold II of Belgium to finance the first formal colonial rule in Central Africa. Moreover, during World War II, rubber was such an important asset to the United States of America that President Roosevelt appointed a commission that concluded that if we fail to secure quickly a large rubber supply, our war effort and our domestic economy will fail. This sparked the idea of manufacturing synthetic rubber. However, it was hard to produce because the polymerization of isoprene would result in cis and trans structures when only cis structures were needed. Significance of organic structure. Rubber is a polymer made of isoprene molecules. Isoprene consists of only 5 carbons and is the smallest repeating unit of any natural polymer. This makes rubber the simplest natural polymer. A new cis double bond forms when isoprene molecules bond together to form rubber. The cis structure is what gives rubber its elasticity. Trans-isoprene polymers are found in gutta percha and bellata and are different from rubber as they are not elastic. Trans-isoprene becomes brittle and hard over time. Natural and synthetic production of the molecule. Rubber is naturally produced as a polymer of the isoprene molecule. Goodyear added sulfur and heat, known as vulcanization, to help make rubber more useful, which stops rubber from melting in the heat of the summer and becoming hard and brittle in the winter because it keeps the rubber molecules in place. During World War II, Germany produced styrene butadiene, also known as SBR, as artificial rubber because it had similar properties to natural rubber. Germany released the SBR patent to the United States, which allowed their synthetic rubber production to go from 8,000 tons in 1941 to 800,000 tons in 1945, making it the second greatest feat of engineering and chemistry of the 20th century after the building of the atomic bomb. Synthetic rubber such as Buna-N, butyl rubber, and neoprene were later produced. Ziegler-Natta catalysts, named after their discoverers, were later produced to allow for the synthesis of rubber with either cis or trans double bonds, allowing people to control the properties of the polymers in their synthesis. Applications. Historical uses of rubber are balls, containers, boots, and hats by the Omegas Indians of Ecuador, as well as Indians on the island of Hispaniola. Trans-isoprene polymer in the form of gutta percha has been used as underwater cable coating in golf balls and in medicine and dentistry in splints, catheters, and forceps as a poultice for skin eruptions and as a filling for cavities. In the 19th century, people began to make golf balls out of cis-isoprene with a trans-isoprene coating. Rubber is currently used in coats, hats, overshoes, boots, hoses, engines, erasers, and in the space industry in seals, washers, O-rings, valves, joints, gaskets, belts, shuttles, rockets, spacesuits, and space stations. Vulcanized rubber is used in elastic bands and tires. Interesting facts. The term rubber was coined by English chemist Joseph Priestley in 1770 because it rubbed out pencil marks easier than the eraser that was in place. Additionally, rubber has affected history in negative ways. For example, the extraction of rubber from rubber trees resulted in resource exploitation, especially in the Amazon basin. Furthermore, indigenous populations were not treated fairly, as they did all the labor to extract the rubber, but other people got the riches from it, and people invaded and still invade their land to harvest rubber. Rubber was also used in an O-ring in the Space Shuttle Challenger for NASA without them considering the properties, resulting in rubber getting too cold while up in space and not returning to its proper shape, which caused an explosion due to a gas leak, losing the lives of 7 astronauts. Overall, isoprene has shaped society in the past and continues to do so today, and is very important to life as we know it.